up? It should. It works for me. Okay, but only for 10 seconds. I think I needed to... I thought that I am live on YouTube for the past 2 minutes. After hitting go live, apparently it was stuck loading and I needed to kind of refresh the website or something. Sorry about that. Okay, as I said, quite difficult dynamic programming problems. I started 2 minutes ago, so it doesn't matter. You didn't miss anything. Super egg drop. The first one, then strange printer, then short code review for the binary tree cameras. Hello, programmer. Super egg drop. A very well-known dynamic programming problem. If you Google or if you search on YouTube for this problem, there will be several solutions. Well, I'll show you mine. Maybe it will turn out easier. Super egg drop. There is a huge building with levels numbered from 1 to n. This is n, maybe with a color. This is n. This is 1. This is theoretically 0. You can go to some floor, some level, drop an egg, and this egg either will survive or it will crack open. You need to kind of binary search how high you can go to drop an egg so it wouldn't crack. If you have a single egg though, that's a very stupid problem, because once you go to the middle of a tower and drop an egg, if it will crack, you're done, you lost. How will you check what is exactly the floor limit from which it cracks? Your goal is to print one value, from which floor you need to drop in order to make it crack. From which floor at least. There is some boundary, like, oh, maybe up to this height it doesn't crack, and if you drop from here or above, it does crack. So for one egg, you cannot do anything smart. You just need to try to drop from floor 1. If it doesn't crack, then from floor 2, and so on and so on. But if you have multiple eggs, and that's the problem, I believe, k eggs, maybe it makes sense to drop from the middle, and then either cracks or doesn't crack, and something is left. If this cracks, let's say, so you drop an egg, it cracks, then what do we need to do? We need to still investigate those floors. So the remaining floors to investigate is everything from 1 to 3, and we have k minus 1 x. Actually, let's say that we are now dropping from floor x. Then we are left with investigating floors from 1 to x minus 1, and we have k minus 1x. Or maybe the other possibility is that it doesn't crack. We drop from here and it doesn't crack. Then what happens? Then we know that the mysterious floor, the border from which we need to drop in order to crack, is somewhere higher, like this. We don't know where, but we know it's one of those. So we need to still investigate floors x plus 1 up to n, and we have still k existing x. If egg didn't crack, then we still can use it. And this can suggest to you that we shouldn't drop an egg exactly in the middle, because it's better to have more eggs. We can do more here, we can do faster. The problem should say, I'm quite sure, that we care about the pessimistic case or something like that. Let's see. You're given k eggs and you have access to building with n floors. Each egg is identical in function, and if an egg breaks, you cannot drop it again. There exists that minimal floor from which any egg would break. Each move you may take an egg and drop it from any floor. Your goal is to know with certainty what the value of the at least floor is. What is the minimum number of moves that you need to know with certainty what f is, regardless of the initial value of f? This, in other words, it means that we care about pessimistic case. You can drop from like top floor and just hope that it doesn't crack, and then you know that the minimal floor is n-1, or like you can drop from very high, hope that it doesn't crack, and then you almost know the answer, or you exactly know the answer. But you care about pessimistic case. What if it cracks? You still have a lot of floors to investigate and you're out of x. It's better to drop somewhere in the middle, to choose floor somewhere in the middle, but we prefer to still have more x because that can help us. We can actually do some example where we will see that dropping not from the middle is a bit better. Yeah, should we go through some example? Just saying that, looking at the chat. Only hard problems today. This is the easiest problem I would say. Then strange printer is actually much more difficult. Strange printer will turn out similar to a difficult problem we covered several weeks ago. It was called, what was it called? We merged k values into one, I remember. I don't know the name. Do I work anywhere? You can read frequently asked questions. I don't work in a company. Just to show you that more x helps. If you have 2 eggs, then if n is free, like that, you can do everything in 2 moves. Then answer will be 2. 2 moves is enough. Because with first move, you check the second floor, the middle floor, and then it will crack or not, but with remaining egg anyway, you can drop from this floor or you can drop from this floor. This is for n equal to 3. But now consider the same case, n equal to 3, but this time with just 1 egg. Why cannot I? Oh, I can. Or just let's move it to the right. Now n equal to 3, so everything is the same, but 1 egg. Then if you drop first egg from here and it cracks, you don't know if the answer is this floor or the one below. Maybe it's enough to drop from here to make it crack, and you're out of x, so you cannot make this move. Sadly, you need to drop from here, then drop from here, then drop from here. And is that the right order? Yes, it is. So we need 3 moves. More eggs can help. Then, indeed, when we split into those 2 conditions, we shouldn't split evenly. Or consider a case where just something completely different example. Let's say that you need to guess a number between 1 and 100, and obviously you care about the worst case, or just let's say from 1 to 10. So I could be able to write down all the numbers. 8, 9, 10. To make it better, let's say from 0. If you can ask a question, is hidden number greater or equal than something, greater or equal or smaller, we would obviously ask about the middle. But consider a case where after asking, If the answer is that the hidden value is greater, then you can use some special magical hat and it will tell you if the number is even or not. If the answer to your query is that the hidden number is greater than 5, then here you will also get information later if this is even or odd. Because this is kind of very artificial and absurd, but let's say so. So you first choose some number, like 5, then somebody will tell you, oh, the hidden number is smaller than that. Then you just continue standard binary search here. But if it's greater, then before you continue, you're given information. The hidden number is odd, or the hidden number is even. Then this seems to be a better case, and maybe we can use fewer queries to find the answer. Then to make those two cases even, the left one and the right one, it's better, slightly better to ask about some number more on the left. And then here this possibility will be a bit bigger, but still we will get information even or odd. So only like here 3 numbers will be possible maybe. And here also 4, so it's quite evenly distributed. In binary search, if you care about pessimistic case, then you should assume that the worst case will happen, the one with more possibilities, the one when you need more moves. That's also some explanation of why here we shouldn't just ask in the middle, because more x helps. So now, quick question, just think for like 20 seconds. Should the optimal x be below or above the middle? Up or down? You can type in the chat what you think. I will reveal the answer anyway in a moment. Remember that if it cracks, then you have fewer x, so that's a worse situation for you. The first answer we have is down. Already 2 downs. 3, 4. Seems to be... Also we have I guess down and I think down. Proxy King says up. Have the first up as well. Okay, also we have some ups. Well, because cracking an egg is worse for us, and then we will go down, because I'm not saying that it's better to move this x down, but if egg cracks, then we will be left with this interval. If egg doesn't crack, then we will be left with this interval. If egg cracks, so we are here, then we are in worse situation. We need more queries. Here we need fewer queries, because we have more x. So to make the situation more evenly distributed, the optimal query will be not in the middle, it will be a bit below. This way, here we have fewer x, but also fewer floors to investigate. Here, more x, but better ability to binary search. So we can then say that, yeah, it's more likely that the number of queries here and the number of queries here in those two cases will be similar, like both 2 and 3 or 2 and 2, something like that. I'm not saying it's exactly that, just that the intuition. This is one explanation why this optimal query point is more to the down, so most people were correct. Another one is that I already said that for number of x equal to 1, we start with the bottom, because we cannot start from the top, because egg will crack and you will know nothing. So for one egg, we start from the very bottom. This already suggests that if we have infinite number of x, then obviously we ask in the middle. If we have one egg, we ask at the very bottom. If we have a few eggs, then it will be somewhere between middle and bottom. Code review today? Yes, after the 2 homework problems. What is more important, to find the magic floor faster or save as many eggs as possible? Only finding the magic floor is important. The problem is about finding the magical floor, the border floor. But more eggs help for that. It's like if you're playing a video game and you need to just get to the end, to the final boss. But for that, maybe in order to kill enemies faster, you need some XP, and then you will be able to kill enemies faster. So it's not that farming XP is important in itself, but it helps. And in particular, maybe you need to make such a decision that right now you will get more XP, you will level up, and then you will be faster. Let's say it's kind of similar, but the goal, the thing you minimize, is the time to reach the boss, or here, the number of eggs. The link command doesn't work on YouTube. I will work on that likely in January or something. I will redo the stream a little bit. It will be more educational. Okay, this thing with middle wasn't that important anyway. It was just understanding of what happens. So we moved down to shorter interval of floors, and we have some remaining number of eggs. And it would be good to know if that many floors are possible, if we need to investigate those floors and we have that many eggs, then what's the answer? What's the minimum number of queries? That's exactly smaller version of the same problem. That's what dynamic programming is about, solving smaller instance of the same problem. And you can do that with iterative or with recursive DP, but first thing you can try, not the optimal one, is this. DP of, let's say that DP of L, R, and K. This will tell us L is minimal floor, R is maximal floor, and K is the number of eggs we have. This will be mean number of queries needed. And that's some example of a definition. DP is about defining the DP state and also about doing the transitions. So that's some idea. But actually it doesn't matter if we are left with investigating floors 1 through 3 or 2 through 4. Because if we know that, oh, the magical floor is somewhere here, then we need the same number of queries as knowing that the magical floor is somewhere here. It's the same. So instead of this, it's better to just do int dp of nk, still minimum number of queries needed, and kind of in brackets, if we are left with n floors and kx. In particular, if n was 1, if there is just one floor, then we know that this is the answer floor. Also, if k is 0, then we cannot do anything. Then we say infinity. We cannot get to the state. Or for k equal to 1, we can make an if for what's the answer. So we will go with this second version because it's for sure faster. And the transitions will be, we just can iterate over all the floors. We can consider dropping an egg from there. And we get down to two possible states. Either we are left with floors from 1 to x minus 1, but because I just care about the number of floors left to investigate, I will just say the number of them is x minus 1, this is the new n. Or this thing, from x plus 1 to n, there are n minus x floors. So I will use dp of x minus 1, k minus 1, and I will use dp of n minus x, k. This second value obviously means the number of x. I will in some way use this. And depending on the problem, sometimes we need to add two dp values or take minimum, maximum, something like that, sometimes even multiply. Maybe very rarely. Here we don't add. If you're given information that this possibility will mean that there are 5 queries needed, and this one means that there are 3 queries needed, then the worst case is this one. What we really need to do is we need to take maximum. Okay, x, yeah, let's drop this. The answer will be, I cannot move like that. Max of this DP and this DP. This is a possible answer if I decide to drop there. And +1 because I'm just dropping one egg. You can think about this as some kind of two-player game where whenever you care about pessimistic case of some process, you can think that you have an opponent. He's a perfect opponent playing optimally, and he always chooses, when there is some random outcome, or not random, he always chooses the worst case for you. He's malicious for you. So if he sees that, okay, you drop somewhere, and now if egg doesn't crack, then you will be left with those floors, and maybe there are so many floors that you need 5 queries in this case. This is the top case, so this, let's say 5. Then he says, okay, egg doesn't crack. Similarly, if you just binary searched from 1 to 100, and you ask about value 50, then you can imagine your malicious opponent choosing between, oh, do I tell him that the hidden value is smaller or greater? That doesn't matter here. But if you instead ask about, let's say, 30, with values from 1 to 100, then your opponent, malicious to you, they will say, oh, the hidden value is greater than 30. What will you do now? You have 70 values to check instead of 50. Considering pessimistic case is the same as having an opponent and he always chooses the possibility worse for you. Hence the maximum of 2 cases. Can we think in the terms of probabilities? No, we shouldn't, because we don't care about probability here. The problem doesn't say that we want some expected value to be good or anything like that. We care about the worst case. It isn't that well formulated in the statement. Here they just say, what is the minimum number of moves that you need to know with certainty what f is, regardless of the initial value of f. So if there exists some value of f such that you need 4 moves, but there exists some other value of f where you need 5 moves, you need to say 5. This statement is equivalent to saying consider the worst case. Hello, Jerry. You got Amazon, Javid, you got Amazon offer or interview? Anyway, you're welcome. I'm happy that my videos help. Oh, you got a job. Congratulations. That's the goal of videos, to help people. The complexity is not obvious. It will be obvious when you consider. So when writing iteratively, it's very easy to consider to compute complexity. We have dp of nk, so for sure already in complexity we have n times k, and then we have transitions multiplied by transition. Transition is just iterating over floor where I want to drop an egg and considering this. N times k multiplied by where there can be n floors to consider, so times n, and that's your complexity, n squared times k. Or even like in drawings it isn't that obvious, so let's do some pseudocode. I will not write the full code. In particular, let's say I don't want to here care about +-1, I just want to move to the strange printer problem, because it's interesting. But it's something like this, with iterative dp. For every n from 1 to n, for every k, the number of x from 1 to k, I want to compute dp of nk. At the end, I will return dp of uppercase n, uppercase k. And what this is? I can choose, so I will iterate over a floor to use to drop an egg from. Right now, let's remember, this n means that I have still n floors to investigate, and I don't care about their indices. Maybe I have 3 floors and they are from 10, 11, 12. That doesn't matter. That's because I don't remember which floors there are. I just say they are from 1 to n, whatever. Just need to know the answer for this smaller problem. For every floor, I consider either moving to state with, let's take a look at drawing. This, I need to rewrite this. X is f, the floor. dp of x minus 1, k minus 1. This is, if my egg cracks, then the number of eggs decreases. And also now I now have bottom floors to investigate. Comma, dp of n minus fk. If doesn't crack, then the number of eggs stays the same, and I have some floors above to investigate. For example, if n is equal 10, and I'm dropping egg on 3rd floor, it doesn't crack, I know that I need to investigate floors from 4 to 10. There are 7 of them. 10 floors minus the 3 that I know aren't the answer. This, and I need to add 1, because I'm just making a move. If there are 5 moves left here, 3 moves in this case, then my malicious opponent takes the worst case, so 5, and I need to add 1 because I'm making a move now. But how do I use it? Do I do something like that? Do I do plus equal? So what is the logic here? Well, I have multiple choices. I decide where to drop an egg from, and I can choose the best thing for me. If I see that dropping from that floor pessimistically gives me 10 moves, dropping from this one pessimistically is 8 moves, I prefer 8. So I take minimum of those possibilities. I will say, let's create a temporary variable, tmp. This is the number of moves, the answer, in case I choose this floor. And then here I do minimum of dp of nk, comma, tmp. And so that minimum would make any sense, I can here just put into some kind of infinity. Int max is actually dangerous because you cannot add 1 to it, so I prefer instead to create my own infinity. Infinity is, for example, 1 billion plus 5. Okay. Int max, as I said, it leads often to overflows. If this dp value is int max, then plus 1 you have an overflow. That's very ugly. You don't want that. Yeah, and you need to initialize something here. You need to care what to put for n equal to 0 or k equal to 1. Whether here you want somewhere to put plus minus 1. You would need to think what exactly means you have that many floors left to investigate. Okay. Does it mean the answer is one of them? Let's remember that initially the answer is between 0 and n. This is that smallest floor. Wait. Floors are from 1 to n. Okay. This is the definition. So the smallest case is that even dropping from 1 cracks, maybe dropping from 2 cracks, and so on. And the last case is that dropping from any floor higher than n cracks, so dropping from non-existing floor n minus 1 cracks. This is equivalent to just saying egg doesn't crack at all. When we say that initially we have those n floors to investigate, what I'm finding exactly is find the first floor from which an egg cracks. And possibly it is n plus 1. You need to keep that in mind when going to those shorter intervals. Like when you see that oh, you drop from 3 and it cracks, then you move to interval 1 up to 2, and you know that possibly maybe from none of those floors it cracks. Maybe you need floor 3, so just above. Just like in general case, you start with interval from 1 to n, and maybe you need n plus 1 to make an egg crack. But if from 3 it cracks, it's a bit strange to go to 4 up to n, because if from each of those it cracks, then wait. If from 3 it doesn't crack, then go there. Does it make sense? Yes, it does, because maybe from 4 it cracks and maybe something more. Yeah, I think everything is okay. I thought that there's something more complicated. I believe that formulas will be exactly like that. Just be careful about, decide what to do for n equal to 0 and k equal to 0. Initialize that. So I will not finish this. There is a solution tab if you want some details later, and if they have iterative solution, they describe here better complexity. I will talk about that in a moment. Complicated stuff. Do they even describe the dynamic programming? It's kind of bad that they don't. They don't describe this solution, only the improved one. They should start from this. Also, with iterative, I told you, it's very easy to compute the time complexity. N times k times n, that's it. It's always obvious with iterative DP. Then let's also talk about binary search. So about this, how to improve this. Well, as I said, it's good to do it somewhere in the middle, but closer to the bottom, because we have more x. If you consider some floor f, and you see that, oh, in this case, I will make a new drawing. There is a high tower. You consider dropping an egg from here. You have some number of eggs. N is, I don't want to count, but let's say n is 10, k is 3. I don't know, maybe. And then you consider those two cases, and you see that if you go to this interval, then the p of shorter interval tells you that the remaining number of queries needed is, let's say, 2. And you go to this interval with 1 egg fewer. Maybe the number of queries needed is 4. I don't claim that those are actual values, but let's say so. Then, if you move this guy up, you will only decrease this value, so still the answer will not improve from 4. No, you need to move with the floor from which to drop down to make those two values more evenly distributed, because you care about their maximum. Right now 4 hurts you. 4 will be the answer, plus 1. 2 doesn't care. You don't want to improve 2 further. You don't want to improve this case. Remember, your opponent chooses an option worse for you. So you want to split in such a point that those two things will be quite evenly distributed. So if you consider something, take a look at those two values. If one of them is greater, we say that it's better to put a split point somewhere here below. It becomes binary search. We consider some floor f. We compare this dp of this, so dp of n minus f, dp of f minus 1. If this one is bigger, then we say that optimal floor f to drop an egg from is somewhere more to the bottom. Again, pseudo code more than actual code is that this transition, we don't consider every floor to drop an egg from. We are trying to search for the best one. We need to do some kind of binary search here from 1 to n, from where to drop, while low smaller equal high. F is the middle point, so let's say this version is easiest. We consider dropping from f, and we compare those two values. Those two. F minus 1, it corresponded to going below because egg dropped. We have now k minus 1, so apparently this floor is enough to crack. Maybe a lower one is good as well. So if this, let's maybe first consider greater. This is situation from the drawing, like 4 and 2. Then the floor should be moved down. So we do this. Else here we actually found the balance point where both things are equal to each other. So we need to just, here we can say exactly what dp of nk will be. And we will not find anything better, because moving to one side can only increase one of the values, so the maximum, and then it will be worse. But even if that doesn't happen, we will find with this way place closest to the balance point. So some final low equal to high we can consider it here, let's say. And this way we change complexity from n square k to n times k times logarithm, because we binary search. We'll write it down. We had a moment ago k times n squared. We improve it to k times n times log of n. I welcome questions in the chat, but also remember, if something isn't clear, or if the pace is too fast, it's perfectly fine to later rewatch this video. On YouTube, I have all past broadcasts of streams. Or you can also check out the solution tab right here. Sometimes also the discuss tab is good. There will be some stuff there, like explaining the logarithm. You're interested in kn log. Anything better than that isn't really important for coding interviews. There are like 10 different techniques to improve dynamic programming in competitive programming. If and else if in the while are the same. Oh yeah, thanks Hawklight. Yeah, this is smaller. In case where this is 4 and this is 2, more like that, then apparently it's better to move this floor from which we drop an egg up. Somewhere here we move to this interval. Here we binary search optimal floor to drop an egg from. How to code binary search on real values? Is it important now? Just repeat something 40 times. Will I ever delete the streams or make them private? I don't see a reason to do it. I would say 99% that they will be public forever. I don't play any DMCA music, indeed. Nobody should copy strike me. Maybe Leetcode will later change every problem will be paid only in premium, and then they will sue me because I show all of that in my streams. So I can imagine some scenarios where I make my past streams private. Okay, we're done with super egg drop. And then we can move to strange printer. Is that fine? Any questions? Do you have or know of a list of specific dynamic programming parent questions? Parent questions? What do you mean by parent questions? That will make it super easy for pattern matching in interviews. No, I'm not aware of any good list of dynamic programming problems for coding interviews. First time watching the stream. Hello, Sadanaria. Streams get deleted from Twitch VODs after a certain amount of time, like 2 months. I think it's 2 weeks, but I store everything on YouTube. No, you shouldn't switch to C++ for interviews. Just use whatever is most convenient for you. How to figure out that question is solved with DP? For every DP problem I kind of comment on that, but also I have lectures on dynamic programming. Watch those lectures. Here's a link to the next problem. Looks like I'm late, but positive infinity, you're just on time for the second problem, strange printer. Link is in the chat. I will remind you the statement and then maybe pause for a moment for everybody to make sure that you understand the statement. I think in previous streams I hurried too much solving problems. I just focused on getting done with the problem, going through solution, that's it. I think that the pace should be more like adjusted to people who aren't me. Like, yeah, if I can solve a problem in 10 minutes, doesn't mean that I should explain it in 10 minutes. I can give more examples. The printer, blah, blah, blah. We are given a string, and we need to create it by repeatedly choosing interval and printing some character there. We start from nothing, and then maybe I will do a sequence of sys. Then I will do a sequence of this, but I will replace some of sys. It's allowed to write on the top of something. Then maybe I will do 2 more sys here. That isn't forbidden. Then I will just remove that. Here write is, and so on and so on. Then I meant the number of characters to be the same. Okay, like that. Given a string, what's the minimum number of operations to create that string? Is the stream gonna be recorded? Yes, everything is later on YouTube. Errichto is not looking at the chat. That's sad. Sorry about that. I never in my life looked at the chat. Okay. Here's an example of a string where it is optimal to overwrite something. If in the input we have A, B, C, D, C, B, A. If you just separately print every character, the number of operations will be 7. Instead, it's better to first print A's like that in the whole string. Then replace the middle part with B's. Then replace the middle part with C's, and then D. This is the third operation. The final fourth operation, remove the middle C, place with D. Oh, I didn't want a different color. I created the same string with not 4 operations. It might be useful to print on the top of something. Now, if characters, like let's say characters A, are in few different places, maybe it's good to first create a long string with A's and then just replace some parts of it, because we saw that, oh, here there are B's, and in some other place there is a single E. It can be more complicated than that, but yeah, this can be done with 3 strings, but only if you first create a long string of A's. That's the statement for you. For string A, B, 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 the answer is 2. We just print one and then the other, or we print a lot of A's and then on the top of 3 last A's we print B's. But for A, B, A, we print A's, and on the top of that we print B. Length of this is not a hint, I would say. Maybe. In coding interview, sometimes you're given usually you're given the problem without constraints, so it's about coming up with the easiest solution. Then indeed it might it might make sense to practice Leetcode without looking at constraints. On the other hand, with interviewer you have some interaction. With problem in Leetcode you don't. Yeah, so a length of the begin string will not exceed 100. In competitive programming, one of hints that problem is about dynamic programming is that constraints are low. If we need to minimize or maximize something, we need to find optimal pattern, optimal sequence, optimal solution. Most of the time it's greedy or dynamic programming. Greedy would be easier, so we can often think first about it, but if you cannot do it greedily, then it's DP. DP is just a general method to, with smaller number of states, consider more possibilities. Can I suggest some other streamers for math and CP related tutorials? Why do you prefer streamers? Short videos aren't short videos better? But I will not say names on the top of my head. Both on my YouTube channel on the side there are recommended channels, and on my GitHub wiki in plans there are like YouTube channels I was going to shout out. Aditya says greedy plus overlapping substructures is DP. I never really think about overlapping substructures when I solve DP. I don't think you ever heard me saying, oh, here we have some overlapping substructures. Maybe it helps to some people, doesn't help for me. N square works, well, you can do around 100 million operations in 1 second, so you can compute yourself when n square makes sense. This is a difficult problem. What I showed here is some information on why greedy doesn't work. It's not that we can say that, well, every part is separate. Also, it would be hard to decide if it's better to connect some A's. For example, let's say that there are A's in multiple places. There are some A's here, some A's there, and something is here. Is it good if there are A's in few places? Is it good to say that the first operation will just write A everywhere as one operation, and then we will move to fixing those shorter intervals? It isn't always the case. Consider this: B, C, B, B, E, B, C, B, B, D, B. If this is the case, then I'm quite sure that it's the best to first write all the B's, because there are so many B's. So just as the first operation, create this string and then write on the top of that. It's bad to just, for example, take character A and say we put A everywhere, and then on the top of that we build other things. Like things like that will show you that this is not a greedy problem. We need to be smarter. We need to consider kind of all possibilities. And when we deal with a string, and well, we can do something in a substring, like we can change everything here to a different character. One idea you might have is to do dp of ij, to say that this is the optimal smallest possible number of moves to create string from position I to position j. But it doesn't really help. It isn't obvious how to do transitions. This time, sadly, and I don't really like that in some editorials where they say, okay, let's do this, those are transitions. In this problem, you can still do it and you can solve the problem, but it's so tricky to understand it. Calculate frequencies of islands of similar characters. That makes sense, but also it isn't correct, because we care about how characters stand next to each other. Like if there is some pattern, pyramid-like pattern, like this one. You need to detect in some way if they correctly, if they allow you to easily be covered with a few stamps, like A's, then B's, then C's, then D's. This is like kind of like bracket sequence structure or a tree structure. I can read Russian alphabet. I don't really speak Russian. I know a few words. Yeah, so dp of ij. There are two paths towards a solution now. One is to think about to make a few observations, and the other is something I already told you when we solved some previous problem about stamps. In problems about stamps, and sometimes in problems where at the end we know what is the final state, it makes sense to consider the process backwards, starting from the final string. Because if we know that this string is there at the end, we can consider the last operation. The last operation can be, for example, to print those two characters A, or to print this single character C, something like that. The last operation for sure cannot be print something there. No. If this is the final string, the one we want to get, then the last operation is one of those intervals of consecutive equal values. Cannot be anything else. For those now joining the stream, we are solving this difficult Leetcode DP problem, strange printer. You can grab link from the chat. Or on YouTube also in the description, I believe. So, idea. We move from the end. Can I print here? Consider the process backwards. And this happens in almost every problem about stamps. If you do something and then you can override that, then it seems that that next operation is more important. And looking at this final string, we can say more about the last operation. For a moment, let's remove this. Later we'll get back actually to some DP. But let's see how to get to that solution, not just have it. Yeah, we can consider every interval here, but what really happens? What really happens after we, for example, have those two AA, and we say that the last operation is to print AA here. Then a moment before that, the string apparently was BCB, and here there could be whatever. This means just and so on. Maybe here these are like question marks, wild cards. Doesn't matter what is here. The problem is now what's the smallest number of operations to create such a string where here I don't care what is right here in those positions. Could be B, could be C, whatever. Then if the next last operation is to deal with this C, also this would turn into question mark, or I could, for example, now say that here I print the B's, 4 B's, and yet previous string would be B, C, question mark, question mark, question mark, question mark, E, B, C, B, A, and so on. If I can do this thing in 5 operations, I can create this. Then in one operation I can put B's everywhere here, and in one more I can put A's everywhere here. If I know how to create this optimally. Maybe that's promising. And here we see that we will maybe deal with some intervals indeed. Like what about now saying that we print this B as the third last operation? This is that, Which b did I say? This one? Right now, there are two intervals with question marks. But of those two intervals of question marks, apparently in those few last operations, I changed that from empty to BAAB. Here we notice the smaller subproblem, the smaller instance of problem from the statement. If I want to create this and then finish to get string from the input, I know that this interval of question marks, it needs to be changed into BAAB. So now we see why it would be useful to use dp of ij. Because I know if right now I have this string, I need to first create it, but then I will use dp from 3rd index to 6th index, and dp of this, I don't know, 10th to 10th, or 9th to 9th, to know what's the number of operations to change this into that. Why question mark doesn't matter? I don't know what you mean. It matters. It represents the fact that it can be anything. Remember that we move from the end. I know that if my last operation is to print AA here, it doesn't matter what this question mark was. If this question mark here, if this question mark is character E, it's fine. I will overwrite it. If this question mark is A, it's also fine. I'm going to overwrite it. You might say, oh, what if it's AA? Then apparently I already changed some question marks to AA. But here I just say that if last operation is AA, then this will give me final string if the string a moment ago had here two question marks. And all this process, thinking process, you don't necessarily need to go through that to get the solution, but it might help to understand what we are doing. Okay, after if the situation is like that, and generally we go from the end, we have this string, and some characters are still like not touched, maybe this B, this C. Some other characters are question marks. Maybe those are question marks as well. Like that. Then here a possible operation is to choose some interval with only one type of character and say that, okay, next last operation is to print this character everywhere in my interval. Here, in this case, it's character C. Just like here, after this was last operation, just print two A's, get two question marks. Given this string, it's allowed to choose such an interval that only one character is there. Because we knew, oh, maybe a moment ago, the operation was to print this character in this interval. This is why those two B's I changed into question marks with one operation, looking from the end. The problem became, given this string, this is the starting string now, you can repeatedly make this operation. Choose an interval where only one character occurs, and maybe some question marks, and change this interval into question marks. And now we say that this is just standard process forward. It isn't backwards. We just change the statement. At the end, I want to get string with just question marks. What's the shortest path from this given string to finally just question marks? And from this string I wrote here, we can get in one operation to B, and then a lot of question marks, a lot of question marks, a lot of question marks, A. This was possible because between any two C's there was just an interval of question marks, and that's allowed. The moment when we indeed take this interval and change this into question marks, it means that we already are done with shorter intervals here, those. So again, would be nice to know dp of ij, the smallest number of operations, to change this initial interval here from I to j to question marks. and then I will say from this index up to this index, I will say, oh, this can be done with maybe 4 operations, this can be done with 1 operation, this can be done with 1 operation. Then in total I need 6 operations here, plus 1 final operation to do this. So dp of this long interval can be 4 plus 1 plus 1, the sum of those 3. This is 6, plus this operation. In total, 7. Idea is that when computing dp of interval, and if there are some characters here equal to each other, then you are allowed to say dp from this L to R, dp from L to R is 1 operation to print those C's, plus before that we need to get done with every yellow interval here, plus the sum over dp of, I don't know, ij, over all those pairs ij between them. This is ij, but you know, this is also ij, just a different one. So here's a solution that is not correct, but almost there. To say that we iterate over every LR, we iterate over character, and well, we know the string from the input because it's in the input. We can find all occurrences of this character, like for B it would be this, this, this in this interval. We can find all B's, and we can take intervals between them. But it's not correct. We don't consider possibility of doing something. I will tell you why it isn't correct. Here I shouldn't really say equal to, just that this is a possibility. But yeah, the idea for a solution is that this is possibility, so minimize with that. Right? This is minimum over this, over all possible characters, like here I said C. To compute dp of LR, iterate over character to use print on last in this interval, and everything in between them, it will be covered, well, before, if we look from the end. What will I do in base case? Store continuous intervals? Yes. That being said, I always think about base case at the end. In non-easy DP problem, the 90% of difficulty is to figure out DP state, to figure out transitions. It doesn't make sense to think about base case if maybe the rest of your algorithm doesn't work. Maybe you realize, oh, actually it isn't DP, it's this other thing. Or actually I don't need that state, I need something else. Like instead of LR, you will need some first character, last character, like the value of them from 1 to 26. So base case, I take care of last. Thank you, Dalknerp, for nice words about explaining hard problems. Nice. I hope so. Okay, wait, as I said, it's wrong. Why? Because this way we say that all occurrences of something like C we get rid of. And it isn't optimal. A, B, C, A, C, B, A. That good? Yeah. If I use this solution I've just described to you, for this string I would get an incorrect answer, I believe. Because if we say that, oh, we consider every character, in particular we consider A, then we kind of say that looking from the end, the first operation is to fix everything with A's, or actually this is the last operation. But we'll be done with those intervals. Each of them needs 2 queries, and then we print A's everywhere, because with 4 queries in total I did A's, question mark, A, question mark, A. 4 operations for that, one more to be done with a's, so answer is 5. Instead, it's possible to do it with 4 operations, not 5. This bad, but 4 good. Because we can, looking from the beginning, we can print a's here, then print b's here, then print c's here, then print a's here. What we see here is that it isn't good to group all characters equal to each other together and to say that they will be printed at the same time. Maybe it's better to just choose some of them. Similarly here, the fact that you see C, character C here, doesn't mean that those intervals should be done independently. Imagine what happens if this is like, let's say E, F, G, H, and here H, G, F, E. This is like a pyramid, and then it's good to print this as E, then F, then G, then H, and then C. Instead of this split into yellow intervals, it's better to say that C is also kind of red, like in this among yellow guys, and to say this interval. Instead of finding all occurrences of character between L and R, it's better to just, we need to say we choose some occurrences of this. And the rest is intervals we do separately. And this makes the problem more complicated. In DP on strings, we generally consider transitions on basis comparing equality of some two characters, then do DP transition. Is it true? That's too abstract, I would say. On basis comparing. I'm showing you now how I think about this problem. So I never said so far that SI is equal to SK. For now, I'm not really talking about code too much. Even this is a mathematical notation so far, kind of. Okay, new problem. Let's remember that given the initial string, this one, I need to change it to a string of question marks by repeatedly choosing intervals and choosing with only one character there and question marks, and changing all those question marks into all those characters into question marks. Like this. I notice that this is B question mark B. I can change to all question marks. And the way to do it optimally, so far I'm not saying how to code it, but this will be optimal, is that, well, even if there are a lot of characters B, for example B, if you want to optimally do this interval, you want to say the following. There will be some yellow intervals. Maybe it's this and that. Maybe not, maybe something else. Each of them you want to do separately. You want to know what's the minimum number of operations to create CBXY. This is a bad example because nothing smart will be done here, but let's at least consider CBC. Why? Because then this can be done a bit faster. Maybe it helps. Okay. In particular, yellow intervals, they can contain character B, even though those B's are at the end. And my goal is to change, to say that this changes into B question mark, question mark, question mark, question mark, B, this. I just focus on this interval. I don't care about E outside. How many operations do I need for that? The number of operations, so this thing right here, it's the sum over dpij, over yellow intervals. Because CBCY I need to change to question marks, and C I need to change to question mark. This is the sum over dpij over yellow guys. And I need one more operation to be done with this string. Because now I say we do b's. Question mark, and so on, question mark. This is +1. To do this interval from L to R, we can do those. And this split into yellow intervals, it is very similar to, as I said, problem from a few weeks ago, the one where we merged k numbers into 1. Maybe some of you will remember that. K into 1. I wrote it in a bit ugly way. Sorry about my handwriting. It looks like quinto 1. I mean k into 1, where we choose k consecutive values, we merge them into 1, and it becomes the sum of them. It's kind of the same. Where to do an interval, we do some smaller dp, like kind of temporary dp or partial dp. If already for every shorter interval you're given information how many operations do you need there, you need to combine that into one big interval. Let's focus on that. You want to do this interval. And for every shorter interval you already counted something. Here 17 operations to change it to be done with this substring. To be done with this substring, 5 operations. To be done with this guy, just 1 operation. To be done with this one, 4 operations. You already have the whole matrix n by n here. And you want to now do this big interval. Your yellow intervals, like I should have a moment ago do everything in yellow, just like I showed you before. You're allowed to leave some characters outside, but it all must be the same character. Like this is allowed. B, 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 B. It will be then one operation. And now, how to do this? We don't need that really in code, but to compute LR, pseudo code. For every L, for every R, so now consider that this is L and R, this is L, this is R. For every character, for example, character B, now do those yellow intervals. Remember, B can also occur here. I showed you a counterexample why we cannot just take all the B's and then say that yellow intervals are taken from between them. That was incorrect. I showed you a counterexample. Or in other words, when you print something, like print a sequence of C's, you still can override that, and on the top of that print another C. This was here. You can later like get back to this moment and show this counter test in red. Okay. Okay, for every character, and here what do we do? We need to go through this interval LR from left to right makes most sense, and I just need to know up to some moment what's the best split. This will be some dp prime or temporary dp. I need to say that dpi is up to position I, what's the best split into yellow intervals. And possibly B is also, and possibly some B's are outside. And we do here transitions from dp to I to some dp of future j with cost I know. So what this really will be, and instead of handwriting, with my ugly handwriting, I will just, let me copy this. It's hard in this software to create a new text. It's something like that. For every I, for every j, consider going from index I to index j, plus cost of ij, like this. Cost ij is cost of yellow interval, so just main dp cost of an interval. This, and also we need to say if next character, so s of I guess, is equal to the special character. In my drawings it was always character b. Then dp of j is equal dp of I, and that's it. We don't pay for that extra, sorry, dp of I plus 1. We can skip one character. But because we move forward, you can imagine that you are a frog, a green frog from here, or I don't know how to draw a frog, so it will be a person. You can jump by something paying the cost of yellow interval, or you can jump by one for free, but only if this character is exactly this special character, ch. This actually should be minimum because you consider that to be the case. It's not that you force this to happen. If we do this, that's slow, but already we have a solution that I hope some of you understand. The complexity, with iterative dp, it's easy to compute complexity. N times n, 26 different characters, that many is possible, times n times n. Iterate here over I and j. That's n fourth times 26. This 26 is a constant. Theoretically, we drop that from complexity, but maybe in some other problem, alphabet would be bigger. So 8 denotes alphabet size. In our problem, this is 26. And if you really understand what happened here, you will see a lot of repeated work, and that allows us very easily to see what to... I can kind of just remove one line here. Chat, tell me what line I need to remove. One of for loops. Which one? My goal is to get, instead of n fourth, n cubic. And I will again summarize the problem. For every LR in the sequence, I want to count the dp for this interval, the answer for this substring. For that, I imagine a frog being a person, because I cannot draw a frog, jumping to the right with either paying cost of yellow interval, shorter dp, or just skipping a single character b. Merge k into 1 was Leetcode 1000. Okay, good to know. So this was Leetcode 1000. Can you get rid of 4r? Yes, exactly. What are we doing after selecting LR? The goal of all of this is to compute, like, oh, okay, maybe this. I iterate over LR in order to say dp of LR is something. dp of LR is defined as the answer for this substring. It's our idea from the very beginning, just that we didn't know how to perform it. This is some other temporary dp, dp prime I will call it. This is for my frog, the way to jump optimally from the beginning. But here, this cost, it's actually the main dp. Or maybe here I will call it uppercase dp. The goal of this whole yellow part is to say, what is dp of LR? I will not fit it here. But after iterating over L and over R, we'll say dp of LR is what? At the end, I will print dp of 0 and -1. Question mark. The goal of this is to compute optimal way to split interval into those shorter intervals and some characters like b. Okay, and who said that? Chill medicine. Yes, you're correct. We can drop this because all of those computations, they don't really depend on R. Where I'm writing stuff with pseudocode, but this is I from L to R. This is also J from, I think, from I to R. But this is just when we finish, to know up to where to compute this temporary dp for a frog. We can skip this final R, and we can say that we jump with our frog till the very end, and it's that at every moment, like here, we know our temporary dp prime of I, and well, we just say dp of from L, the main dp, so the uppercase dp, from L to I is equal this. And as we go from L, we compute the optimal way to jump up to every position. We don't need to compute this, then increase r by +1, and then repeat everything. That's very stupid. No, we remove that. And now instead of saying that we compute dp of lr, we compute dp of l and here everything. That's the goal, but we do it in the same complexity. This doesn't change. It's just that instead of r, we here iterate up to n, or n minus 1, and up to that. And always here we say that dp of li we minimized in this problem. I don't remember now what the problem was about. Yeah, we minimize. We say dp of li is minimum of itself and this temporary dp of a frog. And this way we got rid of this one for loop. So we have now n times 26 times n times n. That's n now cubic. And n cubic times a is good enough in this problem. N being 100, a being 26. It's what, 26 million operations around that. Done. We solved the problem. It turns out it's very, very easy to get rid of this a. We can get rid of this in complexity. And I said that there are two paths towards a solution, to go from the end or to do a few observations. And one of those observations is that it's enough to consider this character b to be the first character in interval. So here, instead of iterating, I could just say, instead of that, actually I will just remove to make space, this character ch is equal s of l. I will shortly explain to you why this is enough to consider. The reason for that is that we deal with some string, and if there are characters b here, it seems strange to, as the first operation, to say cover everything with b's, because in particular unnecessarily we cover the first and last element with that. Instead, if there is character e at the very beginning, maybe with some more, it is optimal to say that the first operation is to use is, and then split the rest into yellow intervals, maybe covering some is. We don't know that. Like, if that was the case, the solution would be much easier, and I told you why it isn't. No, it's more like that. But it is optimal to use e first. Why is it optimal, even if you forget about all our observations? In this problem, why is it optimal to make the first operation to be printing this first character? Because eventually we need to print it. We need to eventually print with is as well. And maybe in optimal solution, first we print here with b's, then we print here with c's, then we print here with e, then we at the very end or close to the end we print here with e. Then I claim that this as well we can do earlier. It doesn't hurt at all. It's just that not to, because apparently this was optimal solution, to use e later. Then it's the same as cutting all those other intervals that were before, not to touch this part, because this part apparently I want to cover with e, and maybe then do some more operations. And then we can do this first. And the result is the same. We will get the same string. If we make our operation on prefix of is, or on some prefix of string, or maybe the whole string first, it doesn't hurt to make it the whole string. And then just if there was this scenario where this was later, I can as well do it first and just cut short other operations. I will also write down this lemma that I used. Maybe in editorial you will find a formal proof. lemma, it's okay for first move to use letter as of 0. Or when we look at some substring from L to R, it's okay in first move to just consider printing character S of L. So obviously for substring S, for substring L up to R, we do this. This was a very short proof, but if you are to later just use character E, you can do it earlier as well. It doesn't hurt. That's the proof. We are done, and we have complexity and cubic. Are there any questions? I think editorial will show you a bit different solution. Also, interesting fact, we are hour and 30 minutes into the stream and I only showed you 2 problems, but well, they were difficult and I didn't want to rush for that. Explanation was amazing. Thank you. I hope so. The solution in this problem has the average rating of 2 stars out of 5. So I think people didn't like this one. But in discussion there are some more. If you want to learn about different solutions, just read discussion, sort by most votes and read some of that. Perfectly, just find the first post with solution in your language. Like if you use Java, use this one. Python, use this one. Next thing, and maybe the final one for this stream. Also, as I said, no homework because next week there will be no stream. Instead, there will be codinggame.com competition. I'm doing short code review. In Discord, I gave you a link to Google form where you can submit your code for binary tree cameras if you did that. If you implement it. If somebody also wants to submit right now, then I will give you a link. But I will prioritize solutions that were submitted earlier. If now I get like 30 submissions, I will not read all of them for sure. Wait, I'm looking for a link. Can you explain the problem from Code Forces? I do that on Saturdays. This is binary tree cameras mission form. Paste it in the chat. Also, I need a problem link for sure. This guy. I'm not sure about the format of this code review. It's treated as an experiment because it is an experiment. No. In Twitch, ! link will give you this new link. Coding bottom DP seems harder to me as compared to recursion plus memorization. How to improve? Practice, starting from easy problems. Watch my YouTube lectures on dynamic programming. I show iterative DP. I don't remember if in YouTube, in the lecture, I talked about bottom up and top down, but I don't really use those names every day. I would just say iterative or recursive DP. But with iterative, you can do more. Once you learn iterative, it is easier. It is harder to learn in the first place. But then code is short, complexity good, constant factor good, and you can do more tricks. Where can we get recordings of all streams on the YouTube channel? I shouldn't have do this. Yeah, you will get a link. In binary tree cameras problem, we are given a tree, well, given a pointer to the root, and every node has pointers to children. Maybe it's null because there is no child. It isn't necessarily a perfect binary tree. We need to place cameras somewhere so that every vertex would have a camera, or it would have a camera in its neighbor. If this is a tree, then it's enough to put one camera right here. If this is a tree, so it has 5 vertices, just like a long path down, we need 2 cameras. Also 2 would be enough for 6 vertices, because it would be like middle of a 3 and middle of a 3, assuming that it's a path. We need to, given a tree, we need to return the minimum number of cameras needed to put there. And a week ago we talked a little bit about some DP here, where we figured that DP on a tree is about returning some information about the subtree. And once we put cameras in a subtree, this is subtree of a left child, subtree of a right child. When I solve difficult competitive programming problems, also this is a drawing I make on paper. And after I already put some cameras here, what's important? Well, it's important how many cameras there are. And also it's important whether I put a camera here. Because if yes, then it monitors the parent vertex as well. But if there is no camera here in this child, then also there are two cases. One is that there is a camera in child of child. So if this is the case, then this vertex is already handled. It's not that we need to worry about it. This subtree is now self-existing. It doesn't help to a parent, but also doesn't require anything. But it can be a case that children of this guy don't have camera, but their children have, so they are covered. And then we force a camera to be here, because this child must be observed. So there are 3 cases. The cases where no, not that big. Okay, can be that big. Case 0 is child has camera. Child doesn't have camera, but it is monitored by its child. Has camera, has his child with camera. Or the 3rd case, child needs camera. Needs camera, it means needs to be observed by a parent. If this is a case, then we are forced, in this last case, we are forced to put a camera here. And if we want to do DP here, for each of those 3 cases, we want to know what's the minimum number of cameras in the subtree. So a subtree, dfs run on this vertex, it should return to you a triple with values like 5, 6, 4. I don't know if those values are possible, but they will. This would mean that there is the best case where child has camera is with 5 cameras in total in this subtree. The best case with this one is with 6 cameras in this subtree, and for the last case, the best is 4. Actually, this will be monotonic or something. I don't think 5, 6, 4 is possible. Whatever, just an example. Also, the right subtree will return some values, let's say 3, 3, 2. And we need to combine that from this root to return my 3 values. Also remember that this isn't necessarily a root of the whole tree. We very rarely apply different logic to the root of the whole tree. Maybe this vertex also has a parent. It's just that when we run for this vertex v, when we run dfs of v, I want dfs of v to return a triple. And maybe it will be used later because this is a child of another vertex, and this is a child of another vertex, and so on. This is just some subtree of the tree in the input. dfs of v should return this triple. And this was homework for you. I promised you some code review, because there are different ways to implement this. Some are better than others. In particular, DP is not the only solution there, and I saw at least one code where it was greedy, but correct greedy. It's like knapsack for each node, right? Either we pick a node to place camera or not. If we place them, no need to place in children's. It isn't knapsack. I see what you're saying, but no, it's far away from knapsack. I don't agree with you. Okay, solution I explained also a week ago. This was just a summary. Codes. Do I want to open Genie? Yeah, I want. Here we go. This is the first solution. No, this is not the first solution. I think the order of links changed. Sorry, I will get back to this. Okay, this is the first solution. Maybe the one from a moment ago was very similar, but just I've read this first and I want to cover it first. Shouldn't it work with node degree value 3? This whole problem can be solved for arbitrary tree. It doesn't have to be binary tree. But in Leetcode, it's more common to get a tree in form of left and right pointer. In coding interviews, binary tree are for some reason more common. In competitive programming, you almost never see them. Just trees are arbitrary. Okay, this is function we need to implement. Given the root, we do something and we return some count. Count seems to be global variable. And we just have a helper function, traverse. This is what I call the DFS. And it returns a single value. So this is not DP. This is greedy. We will also get DP solution. There is at least one DP code submitted. Int traverse. Let's see what it does. It runs DFS. First, when I analyze any code, I don't care about base cases, like here, this being null. So let's for a moment not think about it. We run DFS for left child, for right child. We have some two values. We do something special if they are 0, or actually, okay. Zeros, they mean some state. So here's my code review recommendation. Instead of, first of all, this problem would be terrible with, this code would be terrible without this comment. If you want to use states 0, 1, 2 to denote something, then at least put a comment like this one. And we have camera install, covered and uncovered. I would guess that this means camera is here, means 2. Covered means that your child covers you. Uncovered means that he's in need of help from a parent. Those three states, just in some order. And there are some combinations here. If either child needs cover from me being parent of my children, then I put a camera here. And I increase the global count of cameras. I return 2 because I have a camera. Otherwise, I don't need to put a camera right here, because my children, they don't need help. If at least one of children, they have a camera, then we say that, well, then I'm covered by my children, by at least one child, doesn't matter if by two, so I return the state of covered. Yeah, makes sense. Else, so if it's not the case that one of them has a camera, then I'm not covered. I need help from my parent. And this is the most greedy part. This is the most greedy, questionable part, but it's correct. Is it optimal to do this? If my children, they are covered by their children, like that. Maybe one of them is covered by two. So in this case, if I'm here, can I greedily decide whether to put camera here or not? I don't need to do it. I can do it, and then I will also help my parent. I will cover him as well. But let's notice that it can only be better for the rest of the tree that instead of putting a camera here, it's better to put a camera there. That's the greedy element. We make some observation. Because putting a camera here will cover more vertices, and it is not worse by any way. If we put here, we cover this vertex, well, it is already covered. This vertex, again, already covered. And we cover this vertex. So those two are satisfied. If we instead put a camera here, again, we cover those two, but also we maybe help with those two. So the observation is, if this is the current subtree, and we see that both children are covered by their children, then I don't put a camera here, I just say that my parent will have it. The only exception is if this is the whole tree, then we need to do it. There for sure is an if for that. That's a greedy solution. The more important part of this analysis is about code. So I said that at least you can do is also this, there is an if here, if 0, so if the root is not covered, and we said that, oh, apparently parent needs to be covered, count plus plus, because there is no parent. I need to put a camera there. This is exactly the case where red part is the whole tree. Okay. What is better than using those constants like that? Writing down constants. Make your code self-commenting. It's better style to use uppercase, but it isn't really necessary. And, you know, there is some trade-off. There is a trade-off between typing a lot and making your code easy to read. But if I type this is self-commenting code. It means that one of my children is not covered. Compare it to saying 0, 0. Believe me that if you make a mistake in this code with digits, like with digits 0, 1, 2, it's very hard to debug that. Do this. Then return. And here, I could just say camera install, because I see that this is 2. But let's instead figure this out. If one of my children is not covered, I need to have a camera here. This is why I increase by 1. And this exactly means I have a camera. Else, if I'm covered, so if one of my children, they have a camera, in most IDEs you have this suggestion. I never use it. I don't even know a shortcut for that. Enter will work. Yeah, it does. I usually have such short names, so I would maybe use cam here or something like that, or just cam meaning camera. I would know what it means. I don't think camera install is the best variable name in competitive programming. Then return what? If they have camera, one of my children, they cover me, so I'm covered. Else uncovered. yes, it's longer. Oh, also this. If I don't exist at all, it's not even a leaf. I don't exist. Some child asks some leaf asked about its child. Some vertex asked about its child and it doesn't exist. Then I say I'm covered. I just assume that you don't need to worry about me because I don't exist. Finally, if the root is uncovered, but root thought that its parent will put a camera in itself, then we do this. Tab works. Let me check. No, tab works, but only by a single token. Camera underscore install. So enter is better in G. What was the case here? If uncovered. Explain the base case. Like this, I explained like 20 seconds ago. But I can repeat. If some vertex doesn't have a child, but asked about it, here there is null, no child here. What should we return to that parent? What information should we tell him? Should we say that there is a camera here in null? No, because parent will unnecessarily think that he is covered by somebody. That's not the case. Should we say that this is uncovered? So that he is in need of, we need to for sure put a camera here to cover this? That's also stupid. No, instead we should say that this is just covered. Covered means safe. Hey, parent, I'm not giving you any monitoring. I don't have a camera, but also I don't need anything from you. This is like a clear cut saying that this is independent part. This makes sense for empty part. Thanks, Behir 1337. Yeah, that's it. My only recommendation here is const int for, instead of writing down this comment, use names, and then you will be much less likely to make a mistake here. If you make a mistake, it will be much easier to debug. That's my advice. Cool. Let's move on, and now I will also grab some DP solution. If you have any questions about what I'm doing, then sure, tell me. This is a DP, and it's much uglier, so here I might say more about the correctness. Okay, let's, instead of going through this long function, DP, again, it could be called DFS, whatever. It's DP with memorization, and I will also say something about that. It's ugly, but the point of this part of the stream was exactly to go through some ugly code. Min camera cover, this is a function from the problem. We return DP of root 0 and DP root 2. Apparently, we ask DP, we give it a vertex to the DFS function and the state, one of the three possible states. The explanation is here, so let's read it. DP of v0, min cameras used, it might be something I wrote during the stream, and all nodes are covered in subtree of v, without camera at v, at least one child covers v. Let's read that again. So no camera at v. I will make it a bit shorter. No camera at least v, at least one child covers v. This is just, previously we called this covered. Then DP of 1, min cameras used at all nodes are covered, blah, blah, except v, without camera, no child. This is uncovered. So this guy needs a cover from a parent. And finally, with camera at v. Like that. And instead of returning a triple, This person decided to just tell dp function that I want this particular state. So tell me, in this vertex, if the final state I want from here is covered, then what's the minimum number for cameras in its subtree? It is also possible, just you need memorization for that. Instead, you could here return a triple, and then you don't need memorization. That's very important. If you traverse the tree just once, like for root, we'll just ask once for triple from left child and right child. Each of children will ask once for triple from two children. I would say that that is maybe easier, and then you don't need this memorization map. But if you do, then indeed, map needs to be from the state being whatever is here. Almost always this goes as key in a map, a pair of pointer and this state 0, 1 or 2. Base case, let's consider last. Then this is just to check if we need memorization. That's fine. I like the fact that here we create this variable. Some people do this. If map contains this state, then return it. At the very end, we would also have this. That's like 3 times repeated expression. No, instead, create a variable. This, like, also, I would call it state or current state, but now it's also fine. It denotes current state. And indeed, at the end, while returning, we need to say this. This can be one-liner. Return memo now is answer. This is allowed instead of those 2 lines. Not that it's very important. Yes, I am reading chat. Don't ask stupid questions. But I appreciate things about what I'm doing, not something unrelated. And what happens there? This person, anyway, runs dp for left child and right child and grabs all 3 possible states. So it would be just easier to say that some kind of tuple, or could be vector of size 3, L would be dp of left child. If you did this instead, you wouldn't have memorization. Your code would be easier. This was a mistake, to put 0, 1, 2 as argument here. Just make this return a triple. Anyway, if the state is covered, I will assume that it will be easier to read, because otherwise, damn it, it's just ugly. If the state is covered, that answer is minimum of some stuff. And we see a lot of repeated code here. Would be nice to make this shorter. Every line, every repeated line is to consider answer to be something, minimize answer with something. So let's create a function for that. You can create a Lambda function, or with a bit more work, you can move it outside. Perfectly, you want Lambda function in C++. If you get some value, say value, this. Now, if you type consider of something, it will just do exactly this line. If you want to make it uglier, you can make it as a define, but defines are bad. Don't use defines if you don't have to. Those 3 lines you can replace with this. And actually, because I'm so used to competitive programming, I usually just shorten this. And I know the meaning of it. This is so easy. So I see that it's a bit ugly to just make your code shorter. But if you're going to repeat something 10 times, make the name short. So all of that will just become f of the right part. Oh, shorter code, not typing this answer is minimum of answer, means it's easier to modify anything, and also you are less likely to make some stupid typos. Also, thanks to that, I can easily add here printing. This way, if I want to debug, if something doesn't work, I just add this line, and I don't need to add it like after every line here. It would be so bad. And the DP often doesn't work, because you will just get one character wrong in this a lot of ifs. Something doesn't work, and what do? You debug with prints and you see what is wrong. Yeah, each of those lines will be just f of stuff. I will not modify the rest, but you get the drill. Just actually, it's easy. I can do this, right? Sorry about ugly space. Sure. Okay, better. And what do we have? If state is covered, the actual logic, so this part, but thanks to this, I can actually focus on the logic instead of having long lines and like type a lot, modify a lot, being difficult to debug. This is hard to read, so I would name this L covered, L uncovered, and notice that when necessary, I make the names longer, because this helps. Typing answer is minimum of answer, comma something didn't help. But if I do that, and the same with R, this is R, this is R, this is R, and then we can make all of that more meaningful. And consider what was here a moment ago, and imagine this code not working, and you going through the code and analyzing if it does what you expect it to do. I will finish replacing this, and let's see if it's understandable now. If I want to decide about this vertex, and I want to say you are covered by a child, so at least one of the children needs to have a camera. This is maybe both have cameras, maybe left has camera, and then what to put in right. Can we do R uncovered? We can't, because R uncovered means that parent must have a camera there. I want to consider a case where I don't have a camera, because one of my children, or both, has a camera, and the other, it's covered by something else. Hence, this. Self-commenting code. Self-commenting code. It's much easier to understand, rather than this thing. I don't really want to go through that, but I'm almost sure that we can make this better. So let's try to understand. If state is 2, what was 2? 2 was cam install. If I want to install camera here, then what does it mean? It means that my children can be whatever state. Like they can have a camera, they can need a camera from a parent, they can be covered, uncovered, anything. So you know what I will do? This. I allow my children to be anything. So if I know that left, I had a drawing for that. If I know that left child has 3 possibilities, 5, 6, 4, and I consider the case where I put a camera here, I don't care what state you are. I will choose the best one, 4. Same from right child. I will say 4 plus 2, because I put that many cameras there, plus I put a camera here. So just think if maybe you can just say, yeah, I don't care about you, then you take the best state. If you need to count possibilities and you say, I don't care about you, then I would take here the sum of possibilities, L0 plus L1 plus L2. Now, I think you kind of remember what was here at the very beginning, but this is what we have now. And I made it longer with those names. Okay? But this is significantly easier than what we started with, being this. And maybe final remark. Oh, I like the assert false. If you consider a few cases, this was uncovered, if you consider that, oh, maybe this state is 0, maybe 1, maybe 2, it's good to put this assert false. I also do it. Because if you miss something, doing this and getting state equal to 4 for some reason, because you used index or pointer instead of state, it will be hard to debug. Make it easier to notice a mistake, for example on sample test, by putting assert false. Then you see that if assert on line 45 failed, you're sure that something is wrong with state. You save like 5 minutes of debugging. I wrote all cases because it was getting frustrating to think about. You can do that as well. Finally, you need to clear memorization every time in Leetcode because they can run your function multiple times in different tests. In code forces, it would be equivalent to multiple test cases. You need to clear everything global. I think it wouldn't be a case if we did this here inside. I think they create a new class every time. Don't quote me on that. But maybe if you created it inside a class, you wouldn't need to clear here. And finally, there is this. I don't like that. I don't like repeating this because maybe in some other case this will be a bit too small. Create a constant. Can be 1,000,005. Can be this. Like it doesn't hurt to have this as the first line. Like what if here you put a bit too few zeros? This is now 100,000 and maybe there will be a test with 200,000. Is it easy to notice that? Because you will never find a counter test for that just testing by hand with small tests. That's very dangerous. Just do this. N was up to 1,000. But I'm explaining why it's better to put a constant rather than be used to just doing this. By the way, if you need here something like a billion because values are up to billion, will you really sit here and type zeros? Do you want that risk? This is significantly better. And it's just good code style. Maybe not good to do it like that. It would be good to just type it like this. It works in C++, single quotes, but this works as well and it's shorter. Okay, we're done. Questions? I wanted to make this stream today shorter than 2 hours and that failed. So we'll finish in a few minutes at most. Maybe one more code. Or maybe not. If I see something interesting, let me open all. Also, I'm happy that I didn't get tens of submissions. I got 4 in total. So I'm happy about that. I think one more is equivalent to the first one we were looking for, like we were looking at, where the states are -1, 0, and 1. You're not forbidden to use negative values in your states, if that makes it easier for you to think. Again, this is greedy, this is why it's so much shorter. But I'm very happy that somebody did a DP. I hope to review some DP code. This is a problem where both greedy can be used, but DP as well. -1, 0, and 1 makes some sense because maybe 1 would denote a camera here, 0 means I'm neutral, and -1 means I need a camera. I guess exactly that's the notation here. -1 means that I need a camera. I'm in negative bad state. And we return 1 because I'm putting a camera here. And there is also the same if the root needed a camera, we increase the number of cameras. This is also a global thing. And yeah, I think this should be global indeed. It's a bit better programming practice not to make anything global. Like, this is not really global, it's in a class, but perfectly we should here either return a pair or we should take this by a reference. It's a bit better style. And always pass it, but it isn't that important. It's not that you lose like half the points, if there are points, in the coding interview. So if this is convenient, do that. Just maybe mention, yeah, it will be a bit better to hide this in smaller scope, so I would pass this by reference here, but it's just more typing. If it's like on-site coding interview where you type on whiteboard, for sure your interviewer will understand that. Which question is this? If you open Twitch chat, you can always type !link to get the problem. It was binary trick hammers. But that's it. Thank you everybody for watching. I will take a look on Twitch whether I can rate somebody. You can check this schedule here. Even if I'm not live, you can type here !schedule to get my calendar. Also, let me paste it now. Calendar. Because in the next 2 weeks, I will have very irregular streams, a lot of them, because there is Topcoder Open, Finals. I'm one of commentators. The fact that there is here TCO doesn't mean that it will be on my channel. It will be on Topcoder channel. But I will be commentating along with Lewin, just like a year ago. Coding game, yeah, the new game starts and I will do like 4 streams. No Thursday coding interview stream next week or next week, but there will be coding game. Preparing for Facebook. When you program for like 10 years, when you do competitive programming for 10 years, it's not really that before a big competition you will do some extra preparation. Where I can see that commentary. Join the Discord server and you will for sure be informed by that. But also it should be announced on Code Forces. Whom to rate? Sonar again. If you want to check out Sonar Gonul, he does coding game, short problems. Piggy Bank Studios also I raided a few times. Other than that, the stream is ended. I will finish in 1 minute. Do you like music in streams? I never used music with the logic of...
I'm getting kind of snacky though, so I think what I'm going to do is I'm going to go hit a snack.
Oh, he's going to get a snack. Okay, I'm just raiding Sonar Gonul. I always thought that music in stream is very stupid, because if you want to listen to music, you can choose yourself on YouTube. It's bad to force viewers to listen to this particular music, at least in my opinion. Okay, raiding Sonar Gonul. Again, thanks for watching everybody. See you on Saturday, because there will be Code Forces easy problem solving. Bye bye.